Okay, here we go. So 1-5 is describing angle pair relationships. So we're going to make connections between two different angles. Like we're going to show how they're related to each other, and we're going to bring in some special terms about them. So if you're not in your notes, you might want to get there quick because I am not waiting around. We have already used a lot of time. So first thing we're going to talk about is 3 different terms on how angles are related. We've got our first one, which is complementary angles. Complementary angles are just any 2 angles, so it's just 2. Any 2 angles whose measures have the sum of 90 degrees. So if I show you 2 angles and those 2 angles add up to 90 degrees, then together they are called complementary. It means they add up to 90 degrees. They don't have to be touching each other. They could be separate. One could be 20 degrees. The other could be 70 degrees. Any combination that would make 90 degrees are called, when you add them together, would be complementary angles. The other term that sounds a lot like it is supplementary angles. Whenever we have 2 angles and their measures have the sum of 180, we call those supplementary angles. Now here's where I totally dork out, and you can make fun of me as much as you want, but I guarantee every single year I see somebody use this trick. It helps them out come test time. So complementary and supplementary sound a lot alike. They're very similar sounding terms. One of them's 90, one of them's 180. How do I keep from getting them mixed up? So here's my total dork fest, is that this is the way you're going to remember it. So when somebody pays you a compliment, they're like, hey, your hair looks nice today. Something you might do is go, oh, stop. And when you do that with your arm actually makes a 90-degree angle. Oh, stop. So it's totally dorky, but every single year when I have everyone taking the test that goes along with this, I'll see somebody sitting there whispering to themselves. They'll be writing out, and you'll see them go. They'll do it every single time, and they go, because it's one of those things that supplementary, complementary, when you're first learning the difference between the two, it can be a little frustrating because they sound so much alike. So it's a nice little trick to go, it's dumb, whatever. You can do it silently to yourself. You can be like, and you'll know that your arm makes a 90-degree angle when you're like, oh, stop. It's one of those things that people do. Anyway, it lets you differentiate between the two. Finally, we get this term adjacent. Hopefully you've heard adjacent before, even if you're not sure what it means. When 2 things are right next to each other, but in geometry, we talk about 2 angles. So we've got 2 angles that share a common vertex. So I'm going to go to this angle down in the lower left, and if you notice, angle 1 and angle 2 both have the exact same vertex. They have a common vertex, but also they have a common side. Notice that angle 1, this is one of the sides of angle 1, but it's also one of the sides of angle 2. My little example here is this wall right back here. This wall that I'm standing on, putting my hand on right now. Even though I want to, if I were going to bang on that wall or this wall, I would go bang on that wall. Why would I be hesitant to start banging on this wall right now? Mrs. Corey's class is on the other side of this wall. It is her wall from her perspective because she has a class on that side. From my perspective, it is my wall. We share this wall. It is adjacent. Our rooms are adjacent and we share this wall. So when I think about adjacent angles, the things that I think about is there are 2 angles that are kind of like apartments right next to each other. Like I live in this apartment, you live in this apartment, and we kind of have to respect each other and not bang on that center wall. Whereas 2 angles that would not be adjacent angle 1 and angle 2 in this scenario are not adjacent because they do share a common vertex, but they don't share a common side. There's a gap between that wall. So even if the person in apartment 1 started banging on that wall, apartment 2 is cool. They're like, that's not my wall. I'm good. So there is a space between them. So when we're talking about adjacent angles, we're talking about 2 angles that are like next door neighbors. They're right next door to each other. They have a common vertex. They have a common side. So if you notice this second set of complementary angles that add up to 90 degrees, both of these add up to 90. In this case, I can see it because notice here's 90 degrees. Angle 1 plus angle 2 has to equal 90 degrees because it's like that cheesecake all sliced up. But angle 3 and angle 4, I'm not sure. If you tell me they're complementary angles, okay, I believe it because that's what the book is saying. These are complementary. But I know they're not adjacent because they don't have the same vertex. They're not in the same place, and they don't share a common wall. So when we get to supplementary, we have adjacent and non-adjacent angles as well. Notice here is that straight angle that we talked about yesterday. And straight angles, remember, form 180 degrees. So angle 5 and angle 6 definitely together add up to 180 degrees, because notice that little arc of a rainbow there is going to make 180 degrees of a circle. Angle 5 plus angle 6 will definitely equal 180 degrees. And they are adjacent. They are next to each other, and they have a common wall, they have a common vertex, so they are okay to call adjacent, whereas 7 and 8 are not adjacent. They are not like next door neighbor angles. There's a gap between them. There's space between them. They don't have a common wall. All those things that we're looking at to make it look like they're apartments right next to each other, they don't meet that condition. So complementary, 90 degrees. Supplementary, 180 degrees. Adjacent are those next door neighbor angles. They have to have a common wall that they share, that common side. Okay, so now we're going to test that out. It says use the figure to name a pair of complementary angles, supplementary angles, and adjacent angles. So what we're going to do is I'm going to have you guys name a pair of complementary, supplementary, adjacent angles, but what we're going to do is we're going to name them. Nice, that was the first one I saw right there. Right? Putting it to use. Oh, stop. So complementary angles, we know, add up to how much? 90. So we're going to look at all the angles we see up there, and we're going to look for two numeric values that add up to 90 degrees, and then you're going to tell me the names of those angles based on the letters. So you're going to say angle blah, blah, blah. Give me the three letters that make up that angle. And angle blah, 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 we would say those two angles together are complementary. So somebody help me out. Where's a pair of complementary angles? Yes, ma'am. Angle BAC. Okay, that's one. And what is the other one? It's complement.
Angle RST.
And angle RST. Notice if we took those two numbers, 32 plus 58, we would get 90. So somebody must be whistling at me out there. Those two are complementary angles because they add up to 90 degrees. So now let's find a pair of supplementary angles. Supplementary angles add up to what?
180.
180. So somebody find me a pair of supplementary angles up there. Yes, sir?
Angle CAD.
Angle CAD. Let me mark that for everyone. CAD. That's this one right here. And
Angle RST.
an angle RST. Those two together would be considered a pair of supplementary angles because 122 plus 58 degrees is going to be 180 degrees. Perfect. Yes, ma'am? Do what? Yeah, I still have more to do. Don't worry, we're still doing adjacent angles next. Okay, so now we need a pair of adjacent angles. And remember, adjacent angles are next door neighbor angles. They share a vertex. They share a wall. They are next door neighbors. They don't pound on that wall because they would annoy the other person. So somebody give me a pair of adjacent angles. Yes, sir.
Angle CAD.
CAD, that's this one. So angle CAD and CAB. I left a little gap there just so you can see that there's two angles there, but normally there wouldn't be a gap there. Angle CAB. Now you could have written any of those angles, anything up there, you could have written them in the exact opposite order, like flipped them around. The only thing that matters is that center letter, which tells you where the vertex is. So you could reverse them, you'd be okay, but these are an example of a complementary, supplementary, and an adjacent angles. Alrighty, so if you've never played soccer before, they have this thing that you can kind of warm up with yourself. It's a ball return net. You literally just kick the ball against this net, and if you hit it right in that red square, it usually fires back right at you, so that way you can kind of like dribble it, you can play around with it, it doesn't go shooting off in some random direction. So that's what we're talking about here. And it says, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of angle BCE and the measure of angle ECD. Remember that M up there means measure, and what we're talking about is the number value. What is the number? Like, how many degrees are those things? They form supplementary angles with the ground, meaning that those two things have a special relationship. So somebody talk to me about a strategy we could use here as to how to figure out. Here's what we do know from the picture. This one is 4x plus 8, and this one is x plus 2. Let's talk strategy. Yes, sir.
So the two angles are supplementary.
Okay, so what does that mean in just plain English?
So that 4x plus 8 plus x plus 2 is equal to 180.
Good. See what he did there? He took the first angle plus the second angle, and he knows they have to equal 180. The one on the left plus the one on the right, we know they're supplementary, so that means they equal 180. I'm just going to do a little shortcut here. 4x plus x is 5x. 8 plus 2 is 10, is equal to 180. I'm going to subtract 10 from both sides, and we get 5x is equal to 170. Somebody take a moment and tell me what 170 divided by 5 is. 34. Now, if you stopped here and go, yay, I did it, you didn't do it, you found out what x was, you still haven't told me what those angles are. And that's what it's asking, the measure of angle BC and the measure of angle ECD. But you did just find the most important piece to make that happen. So what do I do with this x equals 34 now to figure out what those angles are? Plug them in. So let's go. I have a choice here. I can start anywhere I want. I could do the one on the right or the one on the left. I'm pretty lazy, so I'm going to go for that one on the right because that looks super easy. I've got 34 plus 2, which is going to give me 36. Now, knowing that this is 36, I now have two different ways that I can figure out what the other angle is. Let's talk about two separate kinds of ways now that I've got that piece of information that I could figure out the other angle. Beautiful. She knows that together these are 180 degrees. And if we subtract away the 36 that we already have, our remainder will be the other angle. But let's plug it in for now, just because we know we could subtract it. Let's get used to plugging it in for a little while here. We've got 4 times, oh, my parentheses on the outside, 4 times 34 plus 8. Somebody take a moment and tell me what that is. Yes, sir. 144 degrees. 36 degrees, 144. If I were to add them together, I would get 180. This seems to match the definition of supplementary angles. Okay, I'm going to keep going. If you need to come back to it, don't worry. It'll be on the video, or you can grab it from somebody next to you. All right, two new terms, and these are the ones that are probably the most commonly misunderstood or mistake-making areas. So if you're a little bit tuned out now, tune back in a little bit for a moment. The first one is called a linear pair. These are two angles. They have to be two adjacent angles. If they're not adjacent, they can't be a linear pair. So understand that's the first criteria, two adjacent angles. If they're adjacent, they could be a linear pair. If they're not adjacent, they could not be a linear pair. So here's what it is that we've got two adjacent angles whose non-common sides are opposite rays. So let's talk about what that means. I'm going to look at this one for a moment. Here are two adjacent angles. If you look at it, you see angle 1 and angle 2 are adjacent angles. They're non-common sides, the one that they don't have in common. So here's one that they don't have in common, and here's one that they don't have in common. Those are opposite rays. I think you would agree that those are opposite rays. They go back to back in opposite directions. They form a straight line. It says their non-common sides are opposite rays. So real quick, actually, linear pairs are easy peasy to recognize once you recognize the pattern. That linear pairs always look like a straight line with some sort of angles splitting them up. So even though I went diagonal there, that's still a linear pair. Notice straight line. Here's one angle. Here's the other angle. I could draw it left to right. Straight line. Here's one angle. Here's the other angle. I could draw it upside down. Straight line. Here's one angle. Here's another angle. It doesn't matter which way it's facing. There is a straight line, which means it has 180 degrees on it, and one of those sets of 180 degrees is being broken up with adjacent angles. So notice there, we call that a linear pair. It's a great piece of information to know because you know that those two angles will add up to 180. But, and I say this in a very nerdy kind of math geek kind of way, actually the coolest thing that we're going to see here is something called vertical angles. It actually makes your math life so much easier. It's like once you find out this is true, you're like, seriously, I can do that all the time and I don't need to show any work for this? No, because here's what we've got. A special thing called vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. Now that sounds very nerdy and technical, but here's what it means. So there's two angles. Notice here's one angle. Let's look at angle 4 and angle 5. Those are two angles, and their sides form opposite pairs, two pairs of opposite rays. Notice that here's one pair of opposite rays, and there's also another pair of opposite rays there. But the short version is this. You're going to get vertical angles every single time when two straight lines cross. Two straight lines will cross. You're going to get angles on the top and bottom, left and right, even if it's at a different angle like this. So we've got all the opposite angles. So the angles that are on opposite sides are the ones that are called vertical angles. So pay attention to this part. This guy over here, number 3, is a vertical angle with number 6. They are on opposite sides. Number 4 on top is a vertical angle with number 5 on bottom. I'm about to tell you something special about vertical angles, and you can probably guess what I'm going to tell you about vertical angles by the way I decided to draw those lines in there. What do you think is true about vertical angles because the way that I drew those lines? Right, 3 and 6, the ones on opposite sides, whatever number they are, they will be exactly the same every single time. 4 and 5, whatever number they are, will be exactly the same every single time. Now, I can show you this in the real world. Check this out. Like, turn around for a second. I'm holding up 2 rulers. I'm not going to do anything magical. I'm just going to smack them together however they land. Boom, they landed like that. Look at the top and look at the bottom. They look like the exact same angle. The left and right, they look at the same angle. But what if I just was so good that I could make that happen? It doesn't matter. No matter how I move them, it always happens. The top one and the bottom one changes together, and the left and the right change together. They always match each other whenever 2 straight lines cross. So it doesn't matter where they end up. The top and bottom always match, and the left and right always match, even when I maneuver them. However I try to change it, no matter how fast I do it, it's always going to work out that way. Even if I do it at some weird thing like this, you might be like, but Mr. Higher, that small angle on top, Peppa, that is not the same angle as the one on the bottom. But the truth is it actually is. That little angle that you're looking at the top is the same as the big one on the bottom, but you have to imagine that you can't see the rest of the lines that should be shooting out there. Like, all I need to do is just go, okay, let's extend it. If those lines up there were growing, you'd see it's the exact same angle on top and bottom. You just don't have enough lines on top. You don't have enough length of it to see it yet, that they are exactly the same. It's just this one looks bigger because the lines are longer down there. Exact same angle. The one on top is open just as much as the one on bottom. Vertical angles save you so much time. So check this out. Here's my geek moment where I get all like, oh, this is so amazing. So like, what if I tell you that this is 70 degrees right there? Now, I just made that up. If I said, hey, what if angle 3 is 70 degrees? Well, now you automatically know another angle up there. Which other angle do you know? That 6 is also 70 degrees, but what if I told you you actually know every angle up there? Because if I told you that was 70 degrees at angle 3, then how much is angle 4? How did we get 110? How did we come up with that number? Good, this is a linear pair. Remember a moment ago I said if we have a straight line, and that angle is broken up into 2 adjacent angles, then this must be 180 degrees right there. Well, if I've already represented 70 of it, 180 minus, that's 180 minus 70 leaves me with 110 degrees there. That has to be 110. Well, shoot, now if I only had a way to figure out what angle 5 was there on the bottom. I'm being silly. You guys should be like, yeah, dude, I know what angle 5 is. What? How did you know it was 110 so easily? It's the same as the one on top because those are vertical angles. It helps us find them very easily. Top and bottom are the same. I actually wrote it. It's just not showing up there yet. I think it's delayed. So top and bottom are the same. Left and right are the same. If I wanted to, I could even say that I have other... Oh, good, it caught up. I could say, if I wanted to, even these are a linear pair right there. 70 and 110. Notice another straight line and it's being broken up. I could even say that these are a linear pair right there. Notice 110 and 70 on a straight line. I could even say that these are a linear pair. Notice all these linear pairs that are there. No matter which way, there's like tons of ways of finding the answers on these. So it's a totally nerd fest way. I love it that you can find all these different ways of getting the answer. All right, so now we get into the part that people like the least. It gets into the word problem-y type of areas. It says that 2 angles form a linear pair. So this linear pair is going to add up to how much? 180. We know that they're going to add up to 180. So something plus something is going to equal 180. That is a guarantee. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. So what should I put in there? If one of them is one angle and the other one is 5 times that angle, what could it, 5x, and what's the other one then? X. I've got one angle and another one that is 5 times that amount. So there we go. There's our two angles. And if I add them together, I'll get 180. 5x plus x is 6x equals 180. Divide by 6, and x is equal to? 30. That's one of the angles. How am I going to find the other angle? That's this one right there. X is equal to 30. What's the other angle? You could, but actually I can see it up there. See the other angle? It's right here. 5 times 30? 150 degrees. Are 30 and 150 degrees a linear pair? Sure, they add up to 180. They are definitely supplementary angles. They add up to 180 degrees. Now, I can tell you already, the next slide that we're going to see is the one that people dislike more because it's even more word problemier. I like that word. It's not a word, but it is now. Word problemier. It's more word problemier than the last one. So we're going to get into this one is all about translating regular speech back into nerd speech. So this is what I like, this is where I excel, as I go, let me turn all this regular talk into nerd talk. The measure of an angle is twice the measure of its complement. So here's what I got to do is this is the part that's going to stump people if I don't take a moment and talk about this. I'm going to do something totally weird for a minute, and we're just going to talk like normal human beings so we can figure out what that means. Its complement. Let's pretend that I said, here is an angle that is 40 degrees, and I want to know what is its complement. What is the other angle that are complementary? What's the other angle?
50.
How did you do that?
Because the complement is 90 degrees.
But I mean, what happened mathematically in your head to get 50? How'd you do that?
90 minus 40.
So he said 90 minus what I gave him 40, and he came out with 50. So wait, let's play this game again. Let's say that the angle was 70 degrees, that my angle is 70, then what is its complement? 20. And again, he must have gone 90 minus whatever I gave him will give me that 20. So would you agree that it seems okay that when we're talking about a complement, you just take 90 minus whatever, right? Whatever I say, that's what you're going to do, right? 90 minus that number. Okay, so understand that the word complement really means 90 minus x. It's like whatever you say, whatever you tell me, I'm just going to do 90 minus that number. So check this out. We're going to translate this from nerd speak, and here we go. The measure of an angle. Okay, so there's some unknown angle. What do you guys want to call that? Let's call it x. This word is, what does it mean in word problems? Is equals. When you see that word is twice, what does twice mean? 2 times something is twice the measure of its complement.
I don't get that.
So when we take from words and we need to turn an equation, the measure of an angle, we have an angle, so that's this. That's right here. The measure of an angle is, when we hear the word is, we say equal. Like if I say my age is 41, that means my age equals 41. So that's where that came from. The word twice there means multiply by 2. And then it's twice the complement. And remember a moment ago, you were the exact one who told me that this is exactly how you do a complement, right? Yeah. So I don't know what that complement is, so I can't plug in any numbers yet, so I'm just waiting for the number. You give me the number, I'll plug it in there, and that's the complement. Yes, ma'am?
Why are you using x twice? Shouldn't you be using 2 different letters since you're talking about 2 different things?
Well, there's x and its complement. So let's say that I told you one of the angles was 20. What would you do to find its complement? Right, so if this is 20, the other one is 90 minus 20, right? That's why I didn't switch letters as 2 different things. You give me that number that you're thinking of, and I'm just going to subtract it from 90, and that's what we're going to do. So you'll see it here in just a second why. So now we're actually going to go through and work this out. So we've got x is equal to, now I'm going to do a little distribution here. 2 times 90 is 180, and 2 times negative x is negative 2x. So far, so good? I realize that this part is a little like, what? But it's because whatever the angle is, its complement, you just take 90 minus that number. I'm going to add 2x to both sides. And I get 3x is equal to 180. From there, divide by 3, and x is equal to what?
60.
One of the angles is 60. Now, there are two angles that add up to 90 degrees. If one of them is 60, what's the other one? What is that? The complement of that angle. That's this one. What is the complement of that angle? 30. 90 minus 60. So we've got, I don't know why I did it that way. X 90 minus x, that's the complement, equals 30. You could just write 60 and 30. I'm just showing you that one angle is 60 and the other one is 30. Let's see if it meets the condition. There is one angle and the other one is twice the amount. Here's one angle and this is twice that amount. 30, 60, 60 is twice 30, and together they add up to 90. That's how we work a word problem with these, and these are the hardest ones. I am saying that in the past, I have snuck these in on quizzes and tests and stuff like this. This is the one that gets people because this is the hardest part for them. Why are we saying 90 minus x? Because that's the definition of what a complement is. If I give you a number in your head, what you do is 90 minus that number. You're just waiting for me to say a number. If I say, hey, I'm about to give you a complement, I'm about to give you a number, you tell me it's complement, then in your head, you're basically lining up 90 minus whatever he says. And that's what that is, 90 minus whatever he says. Yes, ma'am.
So I understand like all the numbers and stuff, but
Okay.
what I'm not understanding is the formula. So like why would you put x equals 2 times 90 minus x when it should be y equals? Because you're talking about two separate things. You're
So-
talking about the measure of the complement and the measure of the angle.
I totally get what you're saying. So she's saying there's two separate angles there. Why are you calling them both x? I'm not actually calling them like they're both x. Here's what's happening. Here is one of the angles. We are okay with that part, right? It's the second x. When I try to use x again, that starts to be like, why are you doing that? That shouldn't be. Because really the first angle, like the first angle is okay being x. The second angle, the way I find the second angle is 90 minus whatever the first angle is, right?
Oh, okay.
So whatever angle the first one is, I'm going to do 90 minus that number, and that's how you find the second angle. This whole thing is the second angle, but to find it, I got to do 90 minus whatever the other number is.
Okay.
Cool. All right, real quick, here are some things that you can and cannot assume. In geometry, you are not allowed to just assume things unless you can prove it in the picture. So looking at this diagram up here, we're going to refer to this one in the upper right. Here are some things that you can conclude. I mean, it's totally okay to say. First of all these points are coplanar. I could take this and they're all on the same plane, meaning I could basically draw them on the same plane and they would be inside there. That is totally okay to do because I could draw a box around them. That would be our plane that they are on. A, B, and C are collinear. Look at A, B, and C. They're on a straight line. It's totally okay to say, because they are shown on a straight line, to say that they are collinear. It is also okay to say that B, that bottom center letter, is between A and C. Remember, B does not mean in the middle. It just means between two things. This podium right now is between me and you, but it's probably way closer to me than any of you. It still means between. Yes, sir?
Back to the coplanar part, let's say you draw a plane smaller than everything like that, it's still coplanar, right?
Yes, really well. In a diagram, if I gave you something like that, if I drew it outside of there, there's usually a reason why, meaning that something may not be in the plane, but it'll use like dashed lines or something. It would never look like that. If you were going to see this, if I were asking you were it on the same plane, first of all, any of this, because you could just imagine that you could just pick that up and let's lay it on a flat piece of paper. It would fit on that plane. It would go there. A, B, and C are collinear. We covered that. B is between A and C. Now here's where we get to the lines. Lines AC, here's AC, ray BD, this one right here, and ray BE all intersect at that point B. I think we can all see that they all meet up there. That's not something that is a secret piece of information. We can see that. Additionally, angle, bless you, angle DBE, that's this angle right here, and angle EBC, that's this one right here. I'm not making them congruent. I'm just doing those angles to show you which ones I'm referring to. They are adjacent. They are definitely next to each other. They meet that condition. They are neighbors. They are right next to each other. I don't know anything about their numbers. But the one angle I do know about is angle ABC. It's definitely a straight angle, meaning that all of this over here is 180, and all three of these angles over here must be add up to 180 as well. I do know that. I don't know any of the numbers up there. Here are the things that you cannot conclude. Now I'm going to erase that, what I drew up there. Here are the things you cannot conclude that you're going to want to do. Everybody wants to do, but you cannot do, because I get it. You have this gut feeling you want to. Number one, you cannot conclude, these are things you cannot say, is that AB and BC are congruent. I get it. Those two segments down there, AB and BC, they look like they are congruent, but there's nothing that says they are. There's nothing there showing that those two lengths of lines are the same length. Don't do it. Additionally, don't say that angle DBE, this one right here, is congruent to this one right here. I don't have any information that says that. One could be 44 degrees and the other one 46 degrees. They would still look very much alike, but that doesn't mean that they are congruent. The easiest one, and this is the number one mistake that I will try to trap you in. I'm telling you right now, I'm going to try to get you on this. I'm going to give you a diagram like this, and I'm going to try to get you to tell me that that is 90 degrees on the left, even though there's nothing that says that's 90 degrees. If that were 90 degrees on the left, what would it need? The little box. Now it's 90 degrees. Without it, it's not 90 degrees. Never, never assume it, no matter how much it looks at it. It could be 90.00001 degrees, and now it's not 90 degrees anymore. Yes, ma'am?
Now, if they had said that, I mean, obviously here it doesn't, but if they said like DB bisects A and C, then you could assume it was congruent, right?
Yeah, so here's what she's saying. That's actually an awesome statement you made. So she's saying, if you told me that DB, or let's call it ray BD, if this ray bisected angle ABC, meaning it chopped it perfectly in half, that it chopped the 180 in half, then could I call it 90? Yeah, for sure. You just applied a great concept there and you said, well, yeah, if it was bisected. They didn't tell us that though. But if they did, then yeah, you'd be on it. So those are the things you cannot. To make sure that those, if you wanted to show all those things, you would need all this. You would need to show, this would show that the segments are congruent. This would show that the angles are congruent. And this would show that this is a 90 degree over there. So there's a lot of indicators that we use to show those things. If those indicators are not there, don't assume it. All right, let's fly through this real quick. I'm actually going to do the speed version of this because I want to get your quizzes back in your hands. And to do so, I'm going to have to do a lot of things. I'm going to ask you for your input, but I'm going to do a lot of the math here. It says find the measure of angle EFH, which is this one right here. Talk to me about what we see here. How can we set something up to solve this? What do you see in that picture that might help us out?
EFG's 180.
It's a straight angle. This is 180 degrees. So what do I know about those? What can I do to, like, that's a key piece of information. That's 180 degrees. What can I do to start solving this then? If I were to add those two angles together, those linear pair, those next door neighbors, I know that they will equal 180. So 3x and 2x is 5x. Forgive me for going quick here. I just want to make sure I get your quizzes back to you. Is equal to 180. I'm going to subtract 10 from both sides, and I get 5x is equal to 170. Divide by 5 again. This is the same problem we had earlier, and now we've got x is equal to 34. I'm going to plug it in to EFH because that's just what x is. They want to know what is EFH. Cool. I'm going over to EFH. 3 times 34 minus 6. Somebody help me out with that. What's that? What's 3 times 34? Anyone know that? 102 minus 6. (96 degrees). That's a 96 degree angle. All we did is we set up an equation. We knew that they were a linear pair, which means they added up to 180. So that's what we did. We added them together, equaled it to 180, and then solved for x. We're going to do another one almost the same. What type of angles are these? Those two small angles are, what do we call them together? Together they equal 90, so what do we call that? Complementary. So how can I set this one up? Good, same thing, but now they don't equal 180, now they equal 90 because that's a 90 degree angle in there. So we get 3x plus 9 is equal to 81. Oh, sorry, is equal to 90. I just gave away that answer. 90. 3x is equal to 81. What is x equal to? What is it? 27. Now, I can plug it in. In this case, they want to find ABC. That's this one. Let me color it A, B, C. So we get 27 plus 9. What's 27 plus 9? 36 degrees. That's a 36-degree angle. I'm going to leave that up there. I'm going to hit pause on here on the recording.